welcome to another video in the series of videos on data privacy and safe browsing. So in this video, I'm going to discuss what makes a website safe. This video requires that you understand the basics of data privacy, particularly encryption. And there is a video that I have already put out. So in case you haven't seen that video, do make sure to see that video and then come back here so that you can understand this video better. So let's begin. So let's start with a very important concept. There are many computers in the world. Some of them are running Windows operating system. There are many versions of Windows, as you know. Then we have the Linux operating system. There are many Linux flavors or versions out there. Then you have the Apple ecosystem and the Android ecosystem. And these are just operating systems. On top of them, you can install, say, the Chrome web browser or Mozilla's Firefox or Microsoft Edge or Apple's Safari. Now, imagine that there is a classroom with 30-40 children. How does anything get done? Each child is different, they have different habits, the teacher is different. Well, the reason it works is because everybody agrees to a protocol. They speak the same language. They agree to a protocol. For example, when the teacher is speaking, the students will keep quiet. And when the student wants to speak, the student will raise the hand, and so on. So this is why we say that a protocol is important when you want things to run smoothly. The protocol that ensures that the World Wide Web, aka Internet, as people like to equate, the protocol that makes this possible is called the HTTP, the Hypertext Transfer Protocol. Now, you don't need to understand what HTTP is and what do HTTP messages look like, how does it work, etc. What you need to understand is that HTTP is a plain text communication. So, if you remember the concepts we had covered in the previous video, a plain text communication can be stolen very easily. So, remember that we had tried to solve the following problem. We had said that Alice wanted to send a secret message to Bob, but Rob the robber could easily steal it. And we had proposed something called asymmetric encryption to secure the communication between Alice and Bob. So all you have to do now is replace Alice with a browser and replace Bob with the server of your bank, and you have a high-level picture of how the internet today works. So this method of communication where there is encryption happening before HTTP messages are sent out is called HTTPS. Very important that you remember that there is an HTTP and there is a secure version of HTTP called HTTPS. So here is basically what happens. The browser says to the server, hey bro, I want to communicate with you. Can you give me your public key? And the server says, sure man, here you go. Then the browser uses the public key to encrypt the message. Now Rob can see that message easily, but Rob cannot understand the message. But the server understands the message because the server has the corresponding private key which allows it to understand the encrypted communication. Now here is a problem. Rob is incredibly clever. He has been studying this HTTPS for a very long time. So he decides to play a trick. He creates a fake public key in the name of the bank. So the public key of the bank's server and the public key that is produced by Rob both have like the same owners on it. The name is the same. So what anyone can easily do, or the browser can easily do, is encrypt the communication using Rob's public key. Now when that happens, the bank cannot understand it. Because see, for a given public key, only the corresponding private key can decrypt the message, not any private key. So since the communication was not encrypted with the bank's public key, the bank server cannot understand it. But because Rob has the private key, Rob can understand the message. And that is how Rob can try to steal the data despite you trying to use HTTPS. So the problem that we are facing is the following. We have two keys now. We have the real public key, which we want to use, and we have the public key, fake public key made by Rob. So how do you differentiate between these two public keys and find out which one is real? Well, there is something known as a certification authority, which is an internationally approved group of organizations that actually have very strict procedures in place so that whenever a bank makes their website or anybody makes their website, they can go to these certification authorities, give them their public key, and the certification authority will do what is called as electronic signing of the public key, which allows the browser to understand whether this public key that it holds in its hand is a real public key or not. So the slight modification in the steps we had mentioned earlier would include that after the browser has taken the public key from the server, it will contact a certification authority to check whether the public key is real. That is the complete HTTPS picture. Now breathe. I know I have thrown a lot at you, especially if you don't come from a background in computer science and web engineering. I'm going to simplify all of this into some very simple rules that you can follow to make sure that your browsing is done safely. So the simple rules are as follows. If you are on a website and all you are doing is reading from that website, you are not going to click anywhere, you are not going to type anything, you are just going to read some paragraphs or something like that, then it is okay if the communication is HTTP and not the secure HTTPS. However, on any website where you have to type something like your username or password, or say something like Twitter where you'll type a message for the whole world to see, on such websites, always make sure that you are using HTTPS. Now you will ask, okay, how do I ensure that? Well, let's take a look at a few screenshots that I have made for you. So here is a website which is working on HTTP, and the browser shows you a lock symbol on the left side of the address, and there is a red cross on that lock symbol. This indicates that this website is using HTTP, and therefore you should be very careful. It is not secure to use it. Here is another example of a site which is actually using HTTPS. So you can see in the address on the address bar that it is HTTPS://, but look at the lock. There is a lock, but there is an exclamation mark on it. So what that means is that yes, the communication will be encrypted, but the public key that will be used by the browser has not been able to verify whether this public key is real or not. So a good web browser will actually give you a dire warning, like you can see on the screen. For example, it says, warning, potential security risk ahead. So you should immediately become alert when you see such messages and avoid those sites, unless you are a professional who really knows what they are doing. Here is a legitimate site, Google, and you can see a lock symbol, but there is nothing on that lock symbol, no exclamation mark, no cross. This means that not only is it HTTPS, but the public key has been verified by the browser, and this can easily be checked. So make it a habit. Next time, no matter what website you're visiting, just make it a habit to look at the address bar and the symbol of the lock on the left. If you see a perfect symbol of a lock with nothing on top of it, or maybe some browsers actually show you a green colored lock. It doesn't matter. It should be a lock and nothing else. Then it is safe to use that website. Your communication is private. Else, you should be really, really cautious. I hope you enjoyed this video, and please cultivate the habit of safe browsing. I'll see you soon.